Okay, welcome back. Now we're going to look at what is the relationship between current and voltage, and how does it give us this third relationship of resistance. So we're going to define resistance and discuss its characteristics. We're going to name and define the unit of resistance and describe the basic sources of resistors. So we're going to look at some physical identifications and properties for resistors. And then we're going to look at something called the resistor color code. So, by definition, the unit of resistance is the ohm. Resistance, then, is the opposition to current. So, we would think, then, that if we start looking at the mathematical relationships that we're going to start forming between voltage, current, and resistance, there must be some inverse relationship between resistance and current. So we need to start thinking about it. Keep in mind that as the value of the resistance, the amount of resistance goes up, the current should start to go down, and vice versa. As the resistance goes down, the current will start to go up. So we're going to see that when we develop something called Ohm's Law. So again, we're going to create everything in terms of one ohm, and you can see the letter here for omega that we use to define the ohm of resistance exists if there is 1 ampere of current in a material when 1 volt is applied across the material. Okay, so this becomes the basis then for our current voltage relationships, or at least the current resistance relationship. We start looking at opposites or inverses. In this case, as resistance is the impedance or the impeding of electron flow, there must be another way of looking at this in terms of how much electron flow then occurs. So we start to develop an inverse relationship that we call conductance, and we use the letter G for that. It's a reciprocal relationship. The conductance, or the amount of current that's allowed to flow in a material like copper, is 1 over R, or the inverse relationship. And we're going to give this a new unit. So where resistance uses ohms, the unit of conductance uses the measure of Siemens. Okay, back in the day, many years ago when I was a kid, it was called a mho. We took the word ohm and spelled it backwards. But now, today, the standard is the Siemens, and we use the capital S for that. So if we look at a quick example here to determine the conductance, let's say of a 22 K ohm. We're going to get used to using that shortcut relationship, 1,022 times 1,000 ohms of resistor, and we want to know how much conductance it is. Well, we put it in the denominator, we invert it or divide it into 1, and we get 45.5 microsiemens. Okay, micro, 10 to the minus 6. So it's a very, very small amount of current that we're looking at flowing. So with that in mind, that's a brief introduction there to the mathematical relationships. We're going to develop it a lot more. Let's look at what a physical resistor looks like. We know physically what a wire looks like, but let's look at what a physical resistor looks like. So if you went to the parts bin and pulled out a resistor, you might pull out one that looks like this. And you look at it and you see all of these colors on there and you go, okay, how do I know what the value of this thing, how much resistance is loaded into this sucker? So what we do is we look at, in this case, a 4-band color-coded resistor. We've got on the far end, on the left side, the first digit designated by a color red, the second digit designated by a color blue, a third digit becomes our multiplier, the number of zeros following the second digit, and then finally we've got a silver band here is going to give us a tolerance, whether it's no tolerance, 5%, 10%, and we're going to start developing that and understanding how to quickly read the color codes and determine how big or small a resistor we have. So our relationship says if we line up this rainbow looking relationship, you can see that we have 0 through 9 and 5% and 10% for our tolerances. So we have black, brown, red, orange, yellow, green, blue, violet, gray, and white. There are lots of mnemonics and monikers that you can use to help you remember this order, because it has to be in this order, that matches the digits on the left-hand side. So what I would suggest you do is occasionally pull out a piece of paper, write down the order: black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, and silver. And then on the other side, write the numbers. The more times you do this, the more quickly you will be able to learn the resistor color code. So let's look at an example. Let's find the resistance value in ohms and the percent of tolerance for each of these color-coded resistors. So in this case, if we look at it, we can see we have red, we have violet, we have orange, and we have orange, and that's supposed to be silver, not blue. I don't know why it's showing up as blue, but somehow, let's see if I can fix that. Somehow that becomes the value. Okay, I don't see where I can fix that quickly here to fill that. Let's see if I can do it up here. All right, that's better anyway. So silver. So how do we calculate what's going on? Well, if we go back to our table here, keep this handy, and start looking at it, the first value is red, 2. So we have a value of 2 given for the first band. If we go back again, violet is the number 7. So we have violet equals 7. And then the next band, orange, is telling us that we have 3 zeros in this case, or 10 to the third. And then a silver band is plus or minus 10%. So when we take 27 times 10 to the third, or 3 zeros, plus or minus 10%, we get this value for our resistor. Okay, we've got the same problem here with this one. Let's see. Somehow I got gremlins in here, so sorry about that. Okay, so for the next one, brown, black, brown, and silver. Okay, so brown, again, is the number 1. So that's 1. Black is 0, the very first one. And then brown, and then silver. So in this case, we have 1, 0, and 1 0 after it, which gives us 100 ohms. Okay, for the next one then, we've got green, we have blue, green, and gold. So 5, 6, 5, 6, and then 5 zeros, and gold is 0.5 or 0.5% of tolerance. So we have 5 million or 5 milli. Okay, so we have, or mega. So we have 5 meg, little m is milli, 5 meg, 5.6 meg, 5,600,000 ohms at a tolerance of 0.5%. Okay, so that is for a 4-band. Now there are also resistors out there that are 5-band resistors. And you can see that it lines up a little differently. The first, second remain the same. The third, though, is a third digit. And then the 4th band is the multiplier and our percent tolerance. Okay, so it lines up a little differently here, where we have black, brown, orange, blah, 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 right down the line. We have 0.01 and 0.1 and 0.01 for the next band here, whether that's silver or gold. And then finally we have another set of bands, red, brown, green, blue, and violet, that give us our identifiers here for our percentage. So it's a little different. So you're going to have to keep 2 systems handy depending on what type of resistors are color coded. So if we take an example here, again, we have red, violet, black, gold, and red, and you can see what that relates to. 270 times 0.1, which gives us a 27 ohm at plus or minus 2 ohms. Okay, so you just move the decimal point. The next one, 402 ohms, plus or minus 1 ohm. Okay, yellow, black, red, black, brown. And then the next one, orange, orange, red, orange, green. So 3, 3, 2 times 10 to the third, or 1,000, plus or minus a half percentage. Okay, so the only way you learn to do this is to do it. You have to sit down and just start working these through using examples. Okay, so introduction to resistance. When we come back, we're going to take all of these things and put them together and try to determine how we use this in an electric circuit to make some sense of what's going on.